All right, so we're live. All right, guys, so what is the first problem that you guys would like to go over? Number 1? All right. Okay, so the first one. All right, so the first one you have what? 5 to the x equals 12. So since we have a base 5, the only way to get rid of base 5 is to do the inverse, which is take the logarithmic function of base 5. So we're going to take the log of base 5 of 5 to the x. So what you do to one side, you have to do to the other. So you're going to take the log of base 5 of 12. All right, so we good with that? So you have a base 5. So to get rid of the base of 5, you have to take the log of that base. So then we're going to use the power rule. So the power rule says that we take this exponent of the log and it brings it to the front. So now we have x times the log of base 5 of 5 equals, we have the log of base 5 of 12 over here. So the log of 5 is 1, because 5 raised to the first power, right, gives us 1. So our 5 raised to the first power gives us 5, so we have x now times 1. So then that's just going to give us x equals the log of base 5 of 12. So that's our final answer. You can put that in the calculator and get a decimal value, or leave it like that. You can change. Yep, you can change it to base. So to change the base, it would be the log of base or log of 12 over log of 5. Yep. All right. So next question. Yes, Brock. 19. Can we stay on the front side first and then go to the back, so that way we're doing all the same types on. All right, so is there any other ones 1 through 10? Yes, Brock. 3. All right. So number 3 says you have 3e to the 3x equals 12. All right, so in order to start or to solve this problem, we need to get the exponential equation by itself. So we need to get rid of this 3. So what is the inverse of multiplying by 3? Yeah, so we divide both sides by 3. Or multiply by the reciprocal, yes. So then that's going to give us e to the 3x on this side, and over here we have 4. So now I have an exponential equation with base e. So the inverse of an exponential equation with base e is called the natural log, right? Because the natural log is the one that has base e. So we're going to say the natural log of e to the 3x equals the natural log of 4. So once again, we're going to use the power rule to bring this 3x to the front. And then the natural log of e is just 1. So then we have 1 times 3x, which is going to be 3x. On this side, we still just have the natural log of 4. I'm fine with that. If you skip parts, as long as I can see, like if you went from here to I don't know where to here, I don't know. I'm fine. I'm good with skipping. As long as you don't skip too much, as long as you don't skip to the answer. All right, so then our last step would be to divide by 3, so you'd have x equals the natural log of 4 over 3. Whoops, you can't see that. There you go. Yes. Sure. All right, so number 5. So number 5 says that you have 3e to the x plus 7 equals 9. So this is kind of the same thing. We need to get that e to the x by itself. So we're going to subtract the 7 first. Right? So if you subtract 7 from both sides, you get 3e to the x equals 2. divide both sides by 3. And you get e to the x equals 2/3. And then now you need to take the natural log of both sides to get rid of the e, right? So to cancel the e out. So you have the natural log of e to the x equals the natural log of 2/3. So the natural log of e is 1. We use the power rule to bring the x to the front. So then we get x equals the natural log of 2/3. Nope, you can leave it like that or put it in a decimal value. Next question. All right, so let's turn it over to the back side. Yep, go ahead, Brock. Number 8. Nope. So you have to divide the 3. So you're gonna, yeah. So for 8 you have. So this is your equation. So you have to, in order to get this exponential equation by itself, you need to divide by that 3 first. So you divide both sides by 3. So you have 2 to the x plus 6 equals 17/3, right? And then now you would take the log of base 2. Since this has an exponential equation with base 2, you would say the log of base 2 of 2 to the x plus 6 equals the log of base 2 of 17/3. Gentlemen, I am trying to go over this. So the log of base 2 of 2 is 1. We use the power rule to bring this exponents to the front. So we have x plus 6 times 1 is x plus 6. And that's going to equal the log of base 2 of 17/3. And then